All right, so we are a few minutes after 11:30, so we'll get this started. So good morning, everyone. My name is Sean Huber. I'm one of the Automation Systems Group Managers here at Rumsey. Thank you for joining us this morning for Rumsey's ongoing webinar series being hosted by Rumsey Product Specialists. So with that, I will turn it over to Rick Matzik, who is one of our mechanical power transmission consulting engineers, and I will let him continue to expand on the topic of justifying a PT upgrade. Take it over, Rick.
All right, good morning, everybody. I'm just going to start with a little bit about myself. I am Rick Matzik. I'm designated as the Power Transmission Consulting Engineer. I've been with Rumsey for 4+ years and have 20+ years of mechanical and electrical design experience. I worked with OEMs for a long period of time. In particular, I designed control systems and machines for power plants, pulp and paper mills, heavy industrial stuff with a specialization in controls and gearboxes for large conveyors. I also spent a lot of time in engineering management as well. A case study of a project that we did with one of our customers that I tweaked just a little bit to show some more advantages of some of the benefits that we can provide. But the basic project is something that we did do with a customer. What you see there on your screen is a picture of a draw bench. The customer has used this draw bench for 30-40 years. It was originally designed for around 2,000 pounds of draw. What they actually do is they draw a tube into a smaller shape, an existing piece of material into a smaller shape, and they draw it at about 2,000 pounds. They wanted to be able to draw more varying product through and that they wouldn't mind a little bit of energy and maintenance savings. That would be the added bonus. And really the energy and maintenance savings, if you're not changing your process, if you're not making a process improvement to vary your product, which gives you more capability, you have to do. And that's a lot of what we're going to talk about today. The original design was for about 2,000 pounds of draw, and the customer wanted to be able to increase that capacity to 7,000 pounds. One of the unique capabilities that Rumsey has as a distributor that many distributors do not is we do have the capability to model your existing equipment or use your existing models to help us decide what components will be the best to fit into your installation. So the process for upgrading this particular machine was to look at the draw chain itself, which would have to be upgraded because we're looking for 3 times the capacity out of the draw chain. And the existing draw chain just did not have that capacity. In addition to that, the sprocket that drives the draw chain would not be able to drive that new chain. So the first step is to analyze and select components for the draw chain and the sprocket. And then the next step would be pick a new gearbox, the existing gearbox. We're looking at a worm gearbox with a 10 horsepower motor on it. That's what was originally on it. For that, we're also going to take a look at what we might be able to do to upgrade the existing dual roller chain assembly. Chain and sprocket, here's our first step. The challenge is that the new draw chain would be much bigger. All right. So what we need to do is take a look at the existing draw chain, the existing sprockets, and see what their capacity are. And one of the requirements from the customer was to make sure that we did as much as we could to minimize the modifications to the existing structure. So even though these things are going to be a lot higher capacity, these new components, they have to be able to fit into about the same space. So there's a little video here. I'm going to show you, we're going to take these sprockets out. We're going to take this chain out of the existing setup just so you can see where they belong and how they have to fit in. Yeah, so when you work with engineered class chain, there are a lot of different designs for engineered class chain. There's attachment chain, which you can see in some of these pictures. There's some drag chain, which is the bottom left-hand corner. You know, you're going to drag a product through, you know, like wood chips. You're going to drag that off into a hopper somewhere. There's a drive chain, which is in the bottom middle of your screen, and an agricultural chain, which is the bottom right and the top middle. So there are a lot of different engineered class chains. We didn't have to change anything. The existing chain was a drive chain. We're going to go with an upgraded drive chain. It is a roller drive chain, which is a little bit more efficient than just our regular welded chain. It's kind of like an eye chart, but I'm not going to ask you to read anything. The new chain would have to be the same style to fit in the area necessary. But what we're looking to do is we're going to try to make sure that the service factor that existed, you know, because this thing has run for the last 30, 40 years, we're going to try to make sure that the existing service factor was at least maintained or exceeded by the new design. So the existing chain was an MXS 882 roller drive chain, engineered class drive chain, with a working load of 2,500 pounds. So what we were looking at, the original design load is 2,000. So, you know, your service factor is about 1.25 on that. So to get at a design load of 7,000 pounds, to get that, at least that service factor, we had to go with the MXS 1242 chain, which is much bigger. It's a higher pitch. It's about double the size, with a working load of 9,000 pounds. Now we've selected, by the numbers, we've selected what that could be. Now, how do we fit? So a lot of times when you change sprockets, you might use the same number of sprocket teeth. But in this case, if we had done that, the sprocket would have been at least 3 or 4 inches bigger, which would have meant a total redesign of the customer's structure. What we did instead was we actually reduced the number of teeth and found a sprocket that matched really close in size. In this particular case, the pitch radius only varied by about 0.3 inches, so almost a little more than 1/4 of an inch. And we were able to just move the bearings down slightly because we were only exceeding on the pitch radius. We're only exceeding the original pitch radius by about 1/4 of an inch. So the bearings themselves could be maintained, and the original drive shaft could be maintained, while just moving the bearings down a little bit to match up the pitch radiuses to make sure that the surface that the chain was dragging on was maintained. So not much had to be modified. Chain and sprockets. And a lot of engineered class chain manufacturers, they don't provide models. So we did some rough models based on dimensions provided by the manufacturers to make sure that these units, and the little video here I'm showing actually shows those sprockets, the sprocket and the chain fitting in. Now we provided idler sprockets as well, but we're only going to show here on the drive side what we did. So we've got the drag chain and the sprockets fitting into the existing structure. And luckily enough, the structure itself was wide enough that the new chain fit in very easily. One of the other things we did was that to minimize the friction losses on the conveyor bed itself was we added a UHMW nylon slider bed that really helps to lower your operational losses by reducing the friction. And that all along the 30-foot length of this draw bed, that nylon low friction surface was contacting the chain to minimize those friction losses. So here, what we have is pretty much a completion of the design, where the old sprockets are removed and the new chain is put on. And I don't know if my bandwidth is good enough to handle video and audio at the same time. We'll see if I digitize too much while this sprocket replacement takes place. So you can see we actually made the structure transparent, so you could actually see the sprocket being installed on the shaft. So what we were able to do was, because we were able to find the right sprocket to fit into that space, the customer was able to do this with very few modifications to the original structure. And that really can't be done unless you do, unless you do the modeling, unless you do the research and compare those dimensions and make sure that what you're doing is the right path toward the upgrade. Because you were able to change this and increase the capacity of your chain and your sprockets, the new chain and the sprockets will allow a broader range of product to be run on this draw bench. What that means is if your old system was running for maybe 60 hours a week, because you can now run more and bigger and more varied product on the machine, maybe you're getting 80, 90, 120 hours a week on this machine rather than less. So that adds up to increased revenue because you're able to get more product out the door and higher availability of this machine. Moving on to the drive system, the existing drive was an old worm gear and 10 horsepower along with a double roller chain and some sprockets. So here, part of our process is to, or download the models if they're available. And this, kind of take the system apart so that we know what we need to fit on and what we can use. Worm gear, they're very economical. That's what was existing. Gears are a lot lower efficiency than some of the newer gearboxes that are out there. So our goal here was to increase operational efficiency and save costs on runtime by changing over from this worm gear to something a little bit more efficient. The options for the gearboxes could be worm gear. We could go with in this case, the ratio is a little too high to do that. The bevel gear is just a right angle gearbox with a low ratio. Possibility. You could go with a helical worm, but again, you still have a worm in there, so you still have the reduced efficiency. The helical bevel, if you wanted to go with a right angle option, that would keep the motor in the same place as the original design, but there are also other options. You can go with an inline helical gearbox. There's a cut section of that, so you can see what's going on in there. These are much more optimized for much higher ratios than what was necessary here, and for much lower speed applications. And also a parallel shaft. That gearbox fits in certain niches, but it's not something that people use a lot. So we don't use those very often because space-wise there are some niche applications it could be used in, but this one wasn't one of them. What we decided to go with was an inline helical because of its high efficiency, how compact it is, and the customer had some spatial constraints where they actually would rather have the motor point in the other direction, so we didn't use a right angle. They're also very economical. Just an FYI, when you are picking a gearbox, when you're designing an upgrade, it is very important to make sure you understand the mounting position and that is designated to the supplier, to the manufacturer, so that the lubrication is done properly for the gearbox. So the vent plug is in the right place, the drain holes are in the right place, and everything is mounted properly so that you can just install the gearbox and you don't have to move anything around. Efficiency standpoint, one of our reasons for doing this upgrade is to get a higher efficiency. One of the unit comparison on exactly identical between a worm gearbox and a helical. And what we found, we're in an air-conditioned lobby running these things at the same speed. That the worm gearbox ran about 20-some degrees, 26 degrees. Air conditioning about 70 degrees, right? Higher. Not only is the worm box a lot less efficient in the helical bevel, and the worm gears run a lot hotter, which means they just don't last as long. Just like it is the enemy of mechanical. Your loop isn't going to last as long. You're going to have to change it more often, and your gear is just not going to last as long. So the helical gearboxes are a better way to go with most of your newer designs today. We go from the drive side over from the draw chain all the way through the tables. What I really want you to look at here and pay attention to is the service factors, right? So is at least going to provide the same level of service as the existing components, right? So in this, the drive shaft to make sure it could handle the higher load. Drive shaft had a 20 service factor based on the twists, the possible twist capability of if you're going to twist that shaft or not. Right now, you still have a service factor of 5, so we didn't have to increase the size of the shaft. Because we did look at that, because you have to look at every aspect of the design. And even the drive shaft that you think, oh, nobody's going to worry about that. It's going to be fine the way it is. We still look at that. We go to that level of detail. And so we're looking at a gearbox service factor of 1.24 on the existing gearbox, and we ended up with the inline helical that we chose going up with getting a 1.85 service factor. So we actually increased the service factor on that. And the 10 horsepower motor, we were able to, which was just sized right for the application, we got up to a 1.5 service factor, which you see down here, with going with a 30 horsepower. Over here is the existing reduction data, and down here is the new reduction data. So you can see how we matched the ratios relatively, because in a lot of cases, customers want to change their speeds, but in this case, the customer did not want to change their speed. And you can see we are looking at almost a 15% increase in efficiency between the existing setup and the new setup. Does the new inline helical fit? So we sized it to handle a 30 horsepower motor because we tripled load capacity on this gearbox and on this draw bench. So we had to go with a much bigger gearbox to handle that horsepower, the 30 horsepower. So we're going to take the existing drive sprockets, the existing chain off. We're going to drop that gearbox down on to see how it fits in the installation, right? So as you can see, because we had to go higher capacity, push shaft is bigger, but we do check all just to make sure gearbox, your front side shaft covered that. Like anything, so this all modeled in 3D. We model the existing stuff, we pull the gearboxes, and then we install the new stuff. As you can see, that new motor is much bigger because it is 30 horsepower versus 10. So in the end, after we do our comparisons, then we'll just pull that old gearbox off, and now you have your new setup. This is what it's going to look like now. Gearbox and your new motor. Because of the increase in efficiency, because your old motor was probably also a non-premium efficient motor, we now go with a premium efficiency motor and a high efficiency gearbox. So you're decreasing your operational expenses, or at least minimizing the impact of the increased energy usage, because obviously from a 10 horsepower to a 30 horsepower motor, you're going to use more energy, but you're minimizing the impact of that cost increase and still getting the advantage of running more varied product on the machine. And the new gearbox will also save money because of the lower operating temperature. This definitely allows for reduced periods on your maintenance, reduced number of maintenance intervals and a longer gearbox life. What was the drive chain upgrade? So you had a roller chain going from your old gearbox to the new. We like to change some of that old once in a while if you're maintaining it right. It's also maintain it when you change it. Roller chain definitely pinch it. Sometimes I've pinched my fingers and on my bicycle them out, or just trying to fix them, get them back on the sprockets. I use a Gates poly chain. If anybody's familiar with motorcycles, Gates poly chain is actually the chain, the belt that is used to replace the old roller chain that they used to use in all the Harley Davidson motorcycles. They now use this belt. I think the people who are really stingy, they probably still get their roller chain because they don't want to change. But these belts are quieter. They're a little bit higher efficiency. They don't stretch like other belts would because it's a poly chain. It's designed not to stretch. And you don't have to grease them. There's no grease necessary. So dirt doesn't bother them as much as it would bother a chain, because dirt can get into a chain, dust can get into a chain, and you don't need the lubrication that a chain requires. So the software that we use takes all of the operational characteristics into play. All right. So we got a 30 horsepower motor now, 1750 RPM. Take the gearbox speed ratio, look at the center distance, and even the shaft sizes, and what the ratio is of the sprockets. And the software actually spits out a ton of options, right? If you provide the shaft sizes, it'll even give you the taper lock bushings that are necessary to install with those pulleys. A lot of times there's a lot of research to be done there. It takes some time. This software makes it very easy and quick to get it done. And I use this software just about every day. So as you can see here, I've highlighted, you've got your belt part number, your driver pulley part number, your driven pulley part number, and your taper lock bushings, everything that you need to install the new setup. And as you can see, in a lot of cases, when you install a roller chain, you don't necessarily know what it's rated for, but this software actually tells you. If you look right here where my mouse is, this belt, and it's good for engineering documentation. If you're an engineer, working on your OEM equipment, it's good for documentation. You're covered. You know what this is rated for. It's rated for 49.24 horsepower. So you're covered in terms of the ratings. See a little video about how does it match up space-wise. You think you might need a much bigger pulley than a sprocket. Well, this pulley ended up a little bit bigger than the sprocket, and you think you need a really wide belt as well. In this case, we were able to go with 90 millimeter, what, 2.5, 2 3/4 inches, 90 millimeter wide belt to replace this roller chain. Applications, easy to change things out if you need to. Okay, so the application for the belt drive is that you save money on maintenance. Somebody doesn't have to go out there once a month to do it. Some of the most expensive things are paying your people to get out there and do maintenance. And they have more, other things to do. When machines break down, they've got other work to do. Doing PM preventive maintenance kind of falls by the wayside when you're just trying to keep your plant running. Also, the belt is a lot lighter than that roller chain. That double roller chain is very heavy. It's maybe 10, 20 pounds per foot. So trying to install that is also a challenge. So you minimize the pinch points, you make it easier to install and remove. And so you're saving money on maintenance in a couple of different ways with the belt drive upgrade. Rumsey provides is we work from the mechanical side all the way to the controller side. So many times I've worked with other specialists like the motion specialists and controllers and everybody else to make sure that what we're designing mechanically on the front half of the project can also be followed through with connection to the control side. The project that we worked on with the draw bench, we also did drives. We also did controllers. There was also visualization attached to that. So when you're working with Rumsey to take care of a project, we're capable of handling the entire thing and trying to guide and help you and assist you with the entire system, not just the mechanical, not just the electrical, everything from the bottom up to the top. We help with encoders, pressure sensors, load cells, instituting load cells, torque arms, giving you, torque measurement of your application. All kinds of different possibilities are available. We didn't happen to do that on this application, but we have on others. And we will work internally to help present the best options to you as a customer from the mechanical side all the way to the top of the electrical side. Great. What we achieved was increased capacity for your machine, increased availability and uptime. And we did all that with doing very few modifications to the existing structure. And, with that extra uptime, you increase revenue opportunity. The machine might not be running, but it is available to run more and more often. We increase your operating efficiency and reduced operating cost due to the higher efficiency gearbox, higher efficiency belting, the higher efficiency motors. And we were able to lower the operating temperature to reduce or eliminate lubrication requirements so that you have a reduced maintenance cost. So that's how you are able to justify that. All of these advantages give you the ability to go to management or coworkers even and show them how a PT upgrade can actually help save you money in the long run. Does anybody have any questions? That is the end of my presentation.
So Rick, the one thing I guess I would also add in there, and we've seen it kind of across the board, is some of the older machines that have been out there are built very, very well. Lots of iron in them, and you know, ultimately they've lasted and worked for a long period of time. But you know, maybe where they're lacking in some cases is just getting the correct information out of them for the process itself. You know, everything in the world of Internet of Things has to, you know, has a lot to do with, you know, how is my material being made? What is my tensions? What are my torques? All of that stuff can be upgraded on a lot of older machines that probably aren't quite ready to go to the trash heap just yet. But sometimes just needs to be looked at to see what things can be added to them to give you more information around your process. And I think that's one of the main reasons for that one slide you had of just other things we ran into as far as the addition of load cells and other types of items. And some of the vendors that we work with have a lot of that built into actuators and other things that can allow you to get a lot of information out about a particular product. And you know, so hopefully the idea would be, you know, you could take that and fund a job based on the fact that, hey, my machine fundamentally is still built very well. It's going to cost a lot of money to get it out of here. But if we just add some of these other niceties to it, we can get what today's world needs out of the material that we're making. So like in this particular case, we were actually able to help the customer, you know, upgrade capabilities of the machine, but on top of doing that, get better efficiency, better safety, and the big one that Rick, you alluded to, is a lot less maintenance to deal with it just because you're able to upgrade those pieces with just newer technology.
Right. And like you said, that increased diagnostic capability with all the new controllers, with the encoders available, any kind of torque monitoring setup, all that better diagnostic, all those better diagnostic tools can help you justify that upgrade as well. And they give the people who are operating the equipment much more to go by. You know, they're very good for giving you a way to understand what your machines are doing.
All right. Well, with that, up on the screen is Rick's contact information. Feel free to reach out to Rick directly or any member of the Rumsey team. We're more than happy to direct you to the right person for any questions you have. As we had kicked this thing off, please go back and reference our website because we just updated a bunch of new webinar series up through the month of November. So please go out there and reference them, and you'll see different versions, anywhere from controllers and PLCs, IC to another mechanical ones coming up, and I believe that was on just general maintenance around gates and gates belts. So all that stuff is posted, and appreciate everybody taking the time to get on this afternoon. Thank you.